Hey everybody, I want to do some quick demonstrations of conditional operators and conditional statements, which is what is the focus of this week's both the lab and the exercise. As you go through the lab, you're going to cover definitely more things that I'm going to cover right now, but you can watch this one first to help you get oriented with what we're doing here. A conditional statement is a statement in a programming language that basically tests for something. It tests for what's called a condition. And then if the condition evaluates to a true or a false, you can do one thing or the other thing. This is how computer programs make decisions. So far in the assignments where we've done calculations, we haven't made any decisions, right? So let me give you a quick example of this. And we're going to create a program that's going to determine if a number is even or odd. All right, so we'll go ahead and enter and prompt the user to enter an integer, and we'll put that integer in a variable called x. And then I'm going to create my condition. So I use the if statement here, and then I have good practice where I put parentheses around my entire condition, because then if I lump multiple ones together, I have the parentheses, and it's good to have just from a readability perspective. It's more of a style thing, but I prefer to have the extra parentheses here. I'm using the mod operator, which we've learned before. What mod does is it does a integer division of x divided by 2, and it returns the remainder. And so if the remainder is 0, then we know our number is even. And so I'll go ahead and enter that code. And since I have a curly brace here, everything inside the curly braces for this if will execute this block of code here. So I can have other things here if I want, which will execute if this operator results in a true. Right now, all I'm going to do is print out that result. I can also add what's called an if else, and I can say if I can put inside the else clause what happens if this operator returns false. So you can say if this returns true, do this, otherwise or else do this. Okay, so let's try that. Okay, so if I enter number 9, it says 9 is odd. That's good. If I enter number 0, 0 is even, good. So this works. It will give us our answer in either the even or the odd case. Excuse me. Let me show you another example, right? Actually, before I show you another example, I want to give you a common pitfall that I see in a lot of students' code. First of all, we can run this code without the curly braces. Okay, so let's try that and see if that works. Okay, so I will commonly see this type of code. But then let's say that this is a much more complicated code, and for whatever reason, the results aren't showing up how you'd expect. One of the typical things you might do is you might add some additional print statements, or maybe another calculation, and you might do something like that. And you notice that Visual Studio tried to help me there for a second, and I'm just going to ignore that for a moment. And so now if you look at this code and you have Python on the mind, you're going to think that the cout troubleshooting command is going to print only when the else clause is activated. So let's try that. So if I type 9, sure enough that works. But what happens if I enter an even number? I still get that same message. Okay, in other words, if I have an if statement without the curly brace, the only thing that executes as part of that if statement's true is the next line of code, just the next line of code. And the same is true with the else. So you want to put curly braces around your blocks of code even when you have just one line, because I can't tell you how many times I've seen it where it works without the curly brace, but then you add more code and it stops working. And it's a big trap and it's hard to debug. So if I run this now and I enter an even number, I don't get that extra print statement. Okay, so big warning on that one. Just get in the habit of using the curly braces. And I think Python makes this harder because you're used to the white space. Let me just show you really quickly one more time what happened there. If I don't have my curly brace and I'm here and I type hit return, notice that it puts me back here here. And then if I space forward and I add something else, as soon as I hit the semicolon, Visual Studio auto indents for me. So Visual Studio does its best to warn me about this trap. I can't speak for code blocks and CLion and Objective-C if they are as good as Visual Studio on this. Okay, let me show you another program, and I'm just going to paste this whole thing in at once for the sake of time and reducing typos. What I've done here is written some code that's going to tell me if the first number is greater than the second number or less than the number, or if they're the same. So now I'm checking 3 different things. And so I say if x is greater than y, print this statement. Else if x is less than y, print this statement. Else print this statement. And so you can do these daisy chaining of if else, and so on, if you want to have more complicated statements here. So we'll go ahead and run this. I enter 2 numbers that are the same, and it tells me it's the same. It meant that this evaluated to false, therefore we came down here, and it meant that this evaluated to false, which meant we come down here. And remember what I showed in a previous video about using breakpoints and single step. You can step through this to verify that the conditions are working as you expect here. So the most common types of conditions you'll do in programming is going to be numeric checks, right? Things like what I've just shown. Is something equal to 0? Are 2 numbers the same? Is one number greater than some limit? Those are the most common types of conditionals you'll do. You will also do more complicated evaluations of multiple variables, and you'll of course do string and character related comparisons. The lab gives you a bunch of exercises similar to the previous lab where you should just be able to do them in the environment like we're doing now and capture the answers. But I also want to show you a little bit about string comparisons, and then there's an interesting gotcha in C++ we're going to have to watch for. So I'm going to take a couple parts of, I think this is, what problem is this? I don't have the lab open. This is one of the problems in the lab. I think it may be problem 2. And it says, suppose that string 1, 2, and 3 are string variables and they're different subjects, right? And so I've initialized them. And if I did this right, if I followed the lab properly, you'll want to check. The first condition was, is string 1 greater than or equal to string 2? If so, I just said it printed true. And then the second one is string 1 double equal English. Again, and prints evaluate true. So let's try that. When I run that, it shows the first one evaluates true, but the second one did not evaluate true, right? It meant that this if statement evaluated false. And I could have said else see out second one evaluates false if I want to really prove that that worked. But because the code inside the condition here did not trigger, we know that this resulted in false. So let's take a look at this. So let's cover that one first. So this one evaluates to false. And that's because string 1 is the word English with a capital E, but we're comparing it to the word English with a lowercase e. So first lesson here is that strings are literal. You might think they're the same, but they have to match exactly. I'm going to make a slight tweak to this to show you another example. I'm going to put a space after one of them, but not the other. And the same thing happens. English with a space after it does not evaluate to equal English with no space after it. Remember, in strings, every character is important, and it has to be an exact match. So that's the second one. This first one evaluates to true, and so you're going to say, okay, why is English greater than computer science, or equal to and greater than computer science? When you're comparing strings using numeric comparison operators like less than or greater than, it uses basically the ASCII character values of those characters, which fortunately line up with alphabetical order. And so because a E is further along in the alphabet than a C, the numeric value of E is bigger than the numeric value of C, and that's why this one evaluates to true. So you can experiment with that, right? We can do that right now. In fact, we can make string 1 be ABC, and string 2 be ABD. And we'll just get rid of this just to get it out of the way. And let's see what happens there. What did I do? What did I do? I think I took out an extra curly there. No output here, right? Because ABC is less than ABD, right? The first two characters of each are the same, but then that C is less than that D. So you can use numerics to sort things, basically. You can use numerics to sort string values, which is a pretty handy tool. Okay, last thing I want to show you here is a pitfall around string comparisons. I'm going to take rid of that, and I'm just going to paste some code in here, again, for the purpose of time and my tendency to create typos as I type. I want to show you a different way you might declare string variables. And this is using what's called a character array. And there's some nuances here that we're not going to go through today. But if you, and I'm going to get rid of that for now. We'll come back to that. So what I have is string 4 and string 5, both that apparently say the same thing. But when I run this program, it says the result of the comparison is false. And so you say, well, wait a minute, string 4 is ABC and string 5 is ABC. Why does this evaluate to false? And the reason for this is very, very tricky, and it requires an understanding of what are called pointers in memory, which we will cover later in this term. So for those of you that are curious and you could read about this, the issue is that string 4 and string 5 are pointing to different locations in memory. Therefore, by definition, they're different, and the double equal will not work in this case. The double equal works on string variables how you expect, but with character arrays, it doesn't. And so the way that you handle that instead is you use a function which is called string comparison. And so if we run that, we get the result of string comparison is equal to 0. A 0 is good news in this case, right? If I change these, if I change one of them to be different, I get result of string comparison is -1. So a 0 means that they are equal. There's no difference, right? And so string comparison is more commonly used in C++ programs. If this whole string comparison thing went kind of over your head, don't worry about it. I wanted to at least plant the seed, because you may find yourself in these weird situations where you think the comparison should work, but they're not working. And as those show up through the term, we can take a deeper look at them. But for the lab and for the assignment, you can start with what we did here earlier, and you should be able to get going on that. As always, post comments or questions on the discussion board following this video, and we'll talk soon.